Hello students, now I am going to teach trigonometric identities, basic concepts, and using these identities how to prove trigonometric identity problems. In this concept you have three basic identity. One is sin square theta plus cos square theta equal to 1. A second identity 1 plus tan square theta equal to secant square theta, and third identity 1 plus cosecant square theta equal to cosecant square theta. These identities are very useful for proving the trigonometric identity sums. Also it will be useful for that basic proof of all trigonometric expressions. First I will prove this identity sin square theta plus cos square theta equal to 1. Proof of these identities are very important for examination point of view. If you are strong in this proof, you can easily solve any identity related problems. First draw a right triangle at B. Let BAC equal to angle theta. In right triangle ABC, by Pythagoras theorem, AB square plus BC square equal to AC square. Now dividing both sides by AC square, this expression becomes AB square by AC square plus BC square by AC square equal to AC square by AC square. These two gets cancelled. This is AB by AC plus BC by AC whole square equal to 1. AB by AC, adjacent side by hypotenuse. This is adjacent side and this is hypotenuse, this is opposite side. So which is equal to cos theta the whole square. BC by AC, that is at opposite side by hypotenuse, this is sin theta. So sin square theta equal to 1. So how to prove this? This part is very important. Divide by AC square. If you divide by A square, right side becomes 1 and left side become cos theta the whole square is cos square theta, and sin theta the whole square is sin square theta. So draw a right triangle at B, apply Pythagoras theorem, okay, and in this Pythagoras theorem divide by AC square, you will get sin square cos square theta plus sin square theta equal to 1. From this you have two very important results. One is cos square theta equal to 1 minus sin square theta, and sin square theta equal to 1 minus cos square theta. Okay. Second identity 1 plus tan square theta equal to secant square theta. Initial steps are same. A right triangle at B, and this is A and this is C, this is 90 degree theta. In right triangle ABC, by Pythagoras theorem, so what is Pythagoras theorem? AB square yes plus BC square equal to AC square. So this step is very important. Divide both sides by AB square. Divide both sides by AB square. So this expression becomes AB square by AB square, BC square by AB square equal to AC square by AC square. So what is the expression becomes? This expression is 1 plus BC by AB the whole square equal to this is AB square. AB square, which is equal to AC by AB the whole square. BC by AB, this is sin theta. BC by AB equal to 1 plus tan square theta equal to AC by AB, hypotenuse by adjacent side, this is secant square theta. This is a proof of second identity. 1 plus tan square theta equal to secant square theta. Only this stage differs, that is in this Pythagoras theorem, divide both sides by AB square. Okay, divide both sides by AB square. This becomes AB square by AB square, BC square by AB square, AC square by AB square. So this is 1 and this is BC by AB the whole square, AC by AB the whole square. BC by AB, opposite side by adjacent side, tan theta, the whole square is tan square theta, and AC by AB, hypotenuse by adjacent side, that is secant theta the whole square, secant square theta. Two important results. So tan secant square theta minus tan square theta equal to 1, and one more value, tan square theta equal to secant square theta minus 1. These two are the important results derived from this identity. Okay. So this is the proof of second identity, 1 plus tan square theta equal to secant square theta. And the third identity, 1 plus cot square theta equal to cosecant square theta. Assumption is same. Draw a right triangle at B, and measure angle A is theta, and this is C. In right triangle ABC, by Pythagoras theorem, AB square plus BC square equal to AC square. But this stage is very important. Divide both sides by BC square. Divide both sides by BC square. So this implies AB square by BC square plus BC square by BC square and AC square by BC square. This is AB by BC the whole square. This two gets cancelled, 1 equal to AC by BC the whole square, which is equal to 1 plus AB by BC, adjacent side by opposite side. Adjacent side by opposite side is cot theta. So cot square theta equal to AC by BC, hypotenuse by opposite side. What is hypotenuse by opposite side? Yes, it is cosecant theta, cosecant square theta. So the third identity is proved by using Pythagoras theorem and dividing by BC square. And two important results in this case, that is derived from this identity, cosecant square theta minus cot square theta equal to 1, and cot square theta equal to cosecant square theta minus 1. So each identity you have two important results. These two results are useful for proving the trigonometric identities. So far we proved three important identities. The first identity is sin square theta plus cos square theta equal to 1, and the second identity 1 plus tan square theta equal to secant square theta. Third identity is 1 plus cot square theta equal to cosecant square theta. These three identities are very important for examination point of view. Also it will be useful for your further problem solving cases. Okay. So if you know the theoretical concept, you can easily solve any tough sums. So concentrate more on these proof. These are all very important proof for trigonometric identity exercise. Thank you. This problem is related with trigonometric identities and reciprocal ratio. Purely theoretical question. Write other entire trigonometric ratios in terms of tan A alone. In terms of tan A. So first we can write cot A. Cot A equal to 1 by tan A. This is by using reciprocal identity. Next, by using trigonometric identity, because of tan A, the identity is secant square A minus tan square A equal to 1, which implies secant square A equal to 1 plus tan square A. Therefore, the second condition is secant A equal to root of 1 plus tan square A. Third, Once you find secant, its reciprocal cos A equal to 1 by secant A equal to 1 by root of 1 plus tan square A. Cot A over secant A. Once you find cos A, you can find the value of sin A. Sin A equal to root of 1 minus cos square A. Cos square A equal to 1 minus 1 by 1 plus tan square A, which is equal to, if you cross multiply this, 1 plus tan square A minus 1 by 1 plus tan square A. 1 gets cancelled. The answer is tan square A by 1 plus tan square A, which is equal to tan A by root of 1 plus tan square A. This is fourth function. Now fifth function, its reciprocal cosecant A equal to 1 by sin A, which is equal to root of 1 plus tan square A by tan A. Here I am applying a reciprocal concept. For the remaining function, you need to apply this trigonometric identity secant square A minus tan square A equal to 1 from this secant A. Once you find secant A, immediately you can calculate its reciprocal cos A. If you know the value of cos A, you can find the value of sin A, and using sin A, you can find its reciprocal cosecant A. This is other entire trigonometric ratios in terms of tan A using two concepts. One is trigonometric identities, another one is reciprocal ratio. Now you know the technique how to write remaining 5 functions. This is an example for one of the type whenever both the expressions, both the sides LHS and RHS are very big, how to solve that expression. Already I informed, simplify LHS separately, simplify LHS separately and RHS separately. If the final answers are equal, then the original expressions are equal. This is a procedure. Okay. So first take LHS. Cosecant theta minus sin theta into secant theta minus cos theta, which is equal to, see how to simplify this type of expression. Already we discussed so many sums. Change into basic functions. How to convert into basic function? One, of course, reciprocal of cosecant is sin theta minus sin theta into reciprocal of secant theta, that is cos theta minus cos theta, which is equal to 1 minus sin square theta by sin theta, 1 minus cos square theta by cos theta, which is equal to cos square theta into sin square theta by sin theta into cos theta. Now to simplify this, sin square theta, sin theta, cos square theta, cos theta. The final answer is sin theta into cos theta, this is 1. Now this is LHS, now RHS. So what is RHS? 1 by tan theta plus cot theta, 1 by, again the same working rule, change into basic function, sin theta by cos theta plus cos theta by sin theta, which is equal to 1 by, cross multiply sin square theta plus cos square theta by sin theta into cos theta, which is equal to 1 by sin theta into cos theta, which is equal to sin theta into cos theta. Compare equation 1 and 2. From 1 and 2, from equation 1 and 2, what is the expression? LHS equal to RHS. Simplify LHS separately and RHS separately. If the final answers are equal, then the original expressions are equal. This is working rule for whenever both the sides of the expressions are very big or complicated. next problem, prove that cot A plus tan B by cot B plus tan A equal to cot A into tan B. So, one of the special sum, here we have 4 terms, cot A, cot B, tan B, tan A, all the, here angles are A and B, all the 4 types of expressions are there, but right side you have cot A into tan B. How to prove this identical problem? First write LHS equal to cot A plus tan B by cot B plus tan A. So, required to prove is cot A into tan B. We need cot only in terms of A, we need this, and tan B, we need this, we do not need these 2 functions. Then how to simplify? Very simple. Now, fix the numerator as it is cot A plus tan B, cot B, replace cot B by, we need tan B, so replace cot B by tan B, because cot theta is a reciprocal of tan theta, therefore cot B can be written as 1 by tan B, plus we need cot A, we do not need tan A, so tan A can be written as 1 by cot A, 1 by cot A. Now simplify the denominator. If you simplify this expression alone, fix the numerator again, this is cot A plus tan B, cross multiply cot A into 1 plus 1 into tan B whole divided by what? Product of these 2. Therefore, this is cot A into tan B. Now, how to simplify this expression? Do you know what is A by B? Tell me, what is A by B? A by B is nothing but A into B by A. These 2 gets cancelled, answer is B. Using this condition, we can cancel these 2. So, what is the value? This is nothing but cot A plus tan B. This sum and previous sum, the working rule, everything based on the RHS. RHS has cot A and tan B, cot A and tan B we need. We do not need cot B. These 2 functions are not there in RHS. So, replace these 2 functions, cot B and tan A. Cot B can be converted into 1 by tan B and tan A can be converted into 1 by cot A, cross multiplying 1 into cot A plus 1 into tan B by cot A into tan B. These 2 are the same expression, we can cancel as per this condition. Therefore, these 2 gets cancelled and this goes to numerator cot A plus cot A into tan B, this is into cot A into tan B. Therefore, this RHS. Now, we can easily understood this expression, how to prove trigonometric expressions based on the RHS. Type 5. Multiply and divide by conjugate of denominator. How to decide the conjugate of denominator? Very simple. Whenever the denominator expression has identities with the negative sign, for example, secant square A. So, whenever the denominator expression has identities with plus or minus sign, for example, 1 minus sin square A, 1 plus sin square A, 1 minus sin square A, 1 minus cos square A, secant square A minus tan square A, cosecant square A minus cot square A, secant square A minus 1 and cosecant square A minus 1. For all the 6 type of denominator, we can apply the concept of multiply and divide by conjugate of denominator. So, first write the LHS equal to root of 1 plus sin A by 1 minus sin A. Very important, multiply and divide only inside the square root. So, what is the conjugate of 1 minus sin A? Conjugate of 1 minus sin A is 1 plus sin A by 1 plus sin A. 1 plus sin A by 1 plus sin A. The numerator becomes, this is one expression, 1 plus sin A the whole square, and denominator 1 minus sin A into 1 plus sin A, that is 1 minus sin square A, that is cos square A. Both are even powers, second degree, so we can apply the square root concept. 1 plus sin A the whole square is 1 plus sin A, and square root of cos square A is cos A. Splitting into two terms, 1 by cos A plus sin A by cos A. 1 by cos A is secant A, and sin A by cos A tan A. Sin A by cos A tan A. This is type 5 method of multiply and divide by conjugate of denominator. Very important, don't forget, here multiplying everything inside the square root, not outside. This square root removes only at this stage. At this stage the power of both numerator and denominators are even power, that is power 2. Type 3, one of the very important type, method of cross multiplication. Method of cross multiplication, prove that cos A by 1 plus sin A plus 1 plus sin A by cos A equal to 2 secant A, both are reciprocal to each other. So LHS equal to, write the expression again, cross multiplying cos A into cos A, cos square A, plus 1 plus sin A into 1 plus sin A, 1 plus sin A the whole square, by 1 plus sin A into cos A, 1 plus sin A into cos A. Cos square A, if you expand A plus B whole square formula, A square plus B square plus 2AB, cos square A plus 1 plus sin square A plus 2 sin A by denominator. Very important, don't multiply the denominator because already it is in factorized form. Now cos square A plus sin square A, using the first identity, cos square A plus sin square A is 1 and one more 1 is there, plus 2 sin A. So 1 plus 1 is 2 plus 2 sin A, taking out 2 outside, 2 into 1 plus sin A. Now cancelling the common factors, 2 by cos A, that is nothing but 1 by cos A is secant A, reciprocal of cos is secant A, 2 secant A, that is the RHS, so which is equal to this. So this is third type under method of cross multiplication. Just write the expression again, then apply the cross multiplication using the identity A plus B whole square equal to A square plus B square plus 2AB. If 3 sin theta plus 5 cos theta equal to 5, then prove that 5 sin theta plus 3 cos theta, 5 sin theta minus 3 cos theta equal to plus or minus 3. Already we discussed the two sums. The type is squaring on both sides, replace sin square by 1 minus cos square and cos square by 1 minus sin square. You will get one binomial expression, take the square root. These are all the method of learning tough trigonometric identities. Check the 3 sin theta, this is given, plus 5 cos theta equal to 5. Squaring on both sides. So what is the value? 3 sin theta plus 5 cos theta the whole square equal to 25. Okay. Now expand 9 sin square theta plus 25 cos square theta, 2AB, 2 into 3, 6 into 5, 30 sin theta into cos theta equal to 25, squaring on both sides. Now replace sin square by 1 minus cos square and cos square by 1 minus sin square, 9 into 1 minus cos square theta, 25 into 1 minus sin square theta. This term as it is, no change in this term, cos theta equal to 25. Now simplifying this, 9 minus 9 cos square theta plus 25 minus 25 sin square theta plus 30 sin theta into cos theta equal to 25. 25 cancel. Okay. So which is equal to 9 transpose all the expression to the right side, all the expression to the right side. So 25 sin square theta plus 9 cos square theta minus 30 sin theta cos theta, which implies 5 sin theta minus 3 cos theta the whole square equal to 3 square. Taking square root, 5 sin theta minus 3 cos theta plus or minus 3. One of the very important, this is useful for JEE main also. One year JEE main question is this type of problem. So focus more on CBSE as well as NTSE also for JEE main. Now you know the technique of this special method, squaring on both sides, replace sin square by 1 minus cos square and cos square by 1 minus sin square. We will get one binomial expression and then take the square root, and don't forget to write this plus or minus, that is very important. Okay. Prove that cot A plus cosecant A minus 1 by cot A minus cosecant A plus 1 equal to 1 plus cos A by sin A. Again this is the same concept, replace 1 in the numerator by the suitable identity. So first write the LHS cot A plus cosecant A minus 1 by cot A minus cosecant A plus 1. Now replace this 1 by the identity and fix the denominator as it is. So what is that? Cot A plus cosecant A cosecant square A minus cot square A by no change in the denominator, correct. Now factorize the numerator, cot A plus cosecant A minus cosecant A plus cot A into cosecant A minus cot A by cot A minus cosecant A plus 1. Take the common factor. What is the common factor? The common factor is cot A plus cosecant A or cosecant A plus cot A. So balance is 1 minus cosecant A plus cot A. What is the denominator? Rewrite the denominator. Now these two big expression gets cancelled and hence which is equal to cosecant A plus cot A. This is 1 by sin A plus cos A by sin A. 1 plus cos A by sin A. This is RHS. So this is also under the type replace 1 in the numerator by the identity. That identity is cosecant square A minus cot square A. But this is direct sum. But previous problem is indirect sum. First change into the standard identity and then apply the concept. Okay. 1 plus cot theta cosecant theta into 1 plus tan theta plus secant theta equal to 2. This is one special method. Here I will apply that method called method of grouping. No need to multiply all the term by term method. Whenever it is 3 or more terms, always apply the method of grouping concept. Now LHS 1 plus cot theta plus cosecant theta 1 plus tan theta plus secant theta. Change into basic function 1 plus cos theta by sin theta plus 1 by sin theta, 1 plus sin theta by cos theta, 1 by cos theta. Sin theta plus cos theta plus 1 by sin theta. Cos theta, this is minus, 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 minus. Cos theta plus sin theta plus 1 by cos theta. Now take 10 seconds, check is there any simple technique possible. Identify the technique, because numerator contains 3 terms and 3 terms. If you multiply by the regular method, you will get 9 terms. So to avoid that, apply the concept of method of grouping. Now I will assume this has one term, this has one term. A minus 1 into A plus 1 equal to A square minus 1 by sin theta into cos theta. What is A? Sin theta plus cos theta. Okay, this is called the method of grouping. That red color one is called method of grouping. Now expand sin square theta, cos square theta, 2 sin theta cos theta minus 1 by sin theta plus into cos theta, which is equal to sin theta plus cos theta. This value is 1. So 1 plus 2 sin theta cos theta minus 1 by sin theta into cos theta. 1 cancel. 2 sin theta cos theta by sin theta into cos theta. Both gets cancelled. This is 2 and this is RHS. Method of grouping. Already we discussed many sums in this type. So far we discussed all the 15 types, and few types we are discussing more than 10 to 15 sums. Few types we are discussing 3 to 4 sums. Only less number of sums are there. These sums includes NCERT books, R.D. Sharma, exemplar problem, previous year questions. In identity alone, we are uploading more than 80 videos only for one single exercise, because that is the toughest exercise and very important exercise in the whole 10 CBSE mathematics. Prove that sin theta minus cos theta plus 1 by tan theta, sin theta plus cos theta minus 1 equal to 1 by secant theta minus tan theta. One of the very important and very tough type. This type is replace 1 in the numerator by identity. But how to start this problem, that is very important. Look at the RHS. RHS contains secant theta and tan theta, whereas LHS contains cos and sin. So replace the LHS by cos and secant and tan. How to convert sin and cos? Sin and cos to secant theta and tan theta. The concept is divide by cos theta. If it is sin and cos to cosecant theta and cot theta, divide by sin theta. This is a working rule. These two are the tough 4-mark questions and the harsh question. Okay, but start this working rule only by looking the right side expression. The right side expression contains secant and tan, and hence divide by the cos. Okay, so what is LHS now? Sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1. So divide numerator and denominator by cos theta. So this becomes sin theta by cos theta by cos theta 1 by cos theta. Sin theta by cos theta by cos theta 1 by cos theta. So what is the numerator becomes? The numerator becomes tan theta minus 1 plus secant theta and tan theta plus 1 minus secant theta. So already we discussed, if you want to simplify one expression, fix either numerator or denominator. But now I am fixing the denominator, apply concept for the numerator. So what is the denominator now? Tan theta plus 1 minus secant theta. Here tan theta plus secant theta minus 1. This one is very important. Replace 1 by identity, that is a value. So how to replace? Tan theta plus secant theta minus secant square theta minus tan square theta by tan theta plus 1 minus secant theta. Factorize the expression. Tan theta plus secant theta minus secant theta plus tan theta into secant theta minus tan theta by tan theta plus 1 minus secant theta. Take the common expression. What is the common expression? The common expression is tan theta plus secant theta. So balance value is 1 minus secant theta minus into minus plus tan theta by 1 minus secant theta plus tan theta. Both gets cancelled. But here it is in the denominator. Again at this stage, take 10 seconds, think about the working rule. Very simple. Multiply and divide by, again here, multiply and divide by conjugate. So what is the conjugate of this? Into secant theta minus tan theta by secant theta plus tan theta. The numerator is secant square theta minus tan square theta by secant theta plus tan theta, which is equal to 1 by secant theta plus tan theta. So this stage is very important, and this stage is very important. Multiply and divide by conjugate. Multiply and divide by conjugate. Replace 1 by identity. First change into secant and tan, and then replace 1 by identity. One of the very important and a tough question in trigonometric identities.